In this video, we're going to look at solving exponent equations. Now, exponent equations are just algebraic statements that have powers in them. That's all. So this is how we can solve exponent equations. You'll notice that these three examples here have unknowns as either the power or the base. So all of these are considered exponent equations. Now, when I say solving, I mean finding the value that makes each equation true. And at level 1, the solution or value that makes every equation true is always going to be a whole number. So you don't have to worry about nasty decimals. So if you look at the first example, it's asking what power of 3 gives us 27. So a good strategy for tackling this kind of problem is to list the powers of 3. 3 cubed equals 9 times 3, which is 27. And then 3 to the power of 4 is 27 times 3, which is 81. Now, calculators aren't allowed in this exam, so you'll need to find some method of either reliably calculating this or memorizing some of these powers. We can see here that, of course, x must be 3 because 3 to the power of 3 equals 27. And that's all you need to do. There's no working required. You don't even need to do this part over here. Next up, x squared equals 16. So what value, when you multiply it by itself, gives you 16? Well, you might know that the value must be 4, which is just the square root of 16. However, that's only half the solution. You might also know that negative 4 squared equals negative 4 times negative 4. And a negative times a negative is a positive. So that's actually going to give me positive 16, which means that also negative 4 is a solution too. So since I have two solutions, I should label them as x1 and x2. And if you only give one solution to this problem, then you're only giving half the answer, which means that your mark will be downgraded. So please remember to give both solutions. You will know that you have to give more than one solution if this power here is an even number. So if it was x squared or x to the power of 4, x to the power of 6 or anything like that, then there are multiple solutions. Otherwise, there's only one. This last one looks quite a bit trickier. So 2 to the power of x plus 1 equals 64. The way to do this is to figure out what power of 2 gives me 64. So let's list them out. So we can see that the power of 2 that gives me 64 is going to be 6, which means that this power here must be equal to 6. So I can write that out as an equation. And so therefore x must be equal to 5. And we're done. These three are a little bit tougher. Let's have a go. So we want to figure out what this power of 3 is to give us some value. However, it's already being multiplied by 2. So what I can do is divide both sides here by 2, and it will get rid of this part. So now I'm left with 3 to the power of x equals 54 over 2, which is 27. And as we saw from before, 3 to the power of 3 is 27, so x must be 3. Next, 3x squared equals 75. Same thing here, I'm going to divide both sides by 3 to give me x squared equals 75 over 3, which is 25. And then remembering, we have an even power here, so that means that there are two solutions. So my first is going to be the square root of 25, which is 5. The second will be minus 5. Lastly, think about what power of 3 gives me 81. So remember I did that before. 3 to the power of 4 equals 81. Therefore, this power here must be 4. So let's write it out as an equation. Let's solve this. Adding 2 to both sides gives me 2x equals 6. And halving both sides gives me x equals 3. And we're done. Thanks for watching.